Okay, good morning. Hey, today is a little bit cold. People are getting late. Okay, so maybe let's get started with questions. Do you have any problem when you are doing the last week's homework assignment? No problem. What are we doing this week? We are doing from prediction to decision, right? Okay, which means we build a model and make prediction with the model, right? But the point is prediction is not decision, right? They are two different things, right? We use prediction to kind of try to estimate the uncertainty event, the outcome of the uncertainty event, right? Well, let me say it again. We use the model to predict the expected outcome of uncertainty event, right? That's the purpose. And with that, you can try to do some simulation and determine what kind of strategy will lead to the optimum expected outcome, right? That is basically the logic of business analytics, right? Okay, so today we are going to do some more on this predictive modeling, right? Specifically, we will go back to the Tafan case, right? In the Tafan case, we have customers purchase orders, right? Purchase records, right? And with that record, we actually can try to predict two things, right? For every customer, we want to know whether this customer will buy in the next period, right? So this is a kind of a predicting probability, right? We want to know the probability that a customer would come to our store and buy from us next month, next quarter, something like that, right? So that is predicting probability. And the next thing we want to predict is if a customer come to buy from us, how much he will buy, right? So this would be a numeric prediction, right? We're predicting a number, right? Now with these two predictions, we should have a very good idea about the value that this customer will create, the profit that this customer will generate it for our company, isn't it? Right? Yeah.
So the first will be whether they will buy or not. So it will be yes or no.
Yes.
And the second will be a number because it's money.
Yes.
But can we know when they'll buy in the next month?
Yes, but that would be another type of model. When we are going to predict the time before an event happening, well, that will be another story. That is another type of model, but do not have time to cover that. Okay. Usually, that type of event, that type of model, we'll call it survival model. Survival model, right? We can model to do that, but we just do not have time to cover it. Okay. Very good question. No, very good question. Okay, so basically this is what we will do today. We will use predictive model in the context of business analytics, right? Okay, so like as I told you several times, right? Making model is very easy in the R environment, right? You make a data frame and just as long as you have a data frame, right? And in the data frame, they need to have two things, right? First of all, you need to have a target, the outcome variable, right? The target variable that you want to predict, right? You need to have that information. And then you will have some predictor, some predicting variable, or sometimes we call it independent variable, right? So, and given this predicting variable, you want to predict the outcome, right? If you have a data frame like this, right, then you can put that data frame into a method, and that method would create the model for you, right? It's just one function call, right? You just give it the data frame, and tell it what is the outcome, what is the predictor, and then it will give you a model. Okay. Well, of course there are some internal algorithm to build a model, but that is out of the scope of this course. Okay. Yes.
Professor, in real life, like, we get these outcomes because we ask a very specific question.
Yes.
Not just prediction, data analytics in general. You analyze because you ask a specific question, like, this is what I want, can you find it? But is there a way where you find someone without being asked a specific question?
Well, that will go back to the first half of the course, right? The reason that you are interested in something is because after you explore it, you know that something is important to you, right? Right. So you need to understand the general situation, okay? You need to compare the characteristic of different groups, right? So when you have a systematic understanding of your business, then you know which variable is important. Then you'll come up with the question about what I want to predict, right? That's basically why we do exploration before doing prediction. Get it? Okay, it's also a very good question, okay? Now, after you build the model, then if you have some new data coming in, right? You have data, you have this predictor, but you do not have the outcome variable, right? So you will use this model to make the prediction for you, okay? That's basically how prediction model works, okay? You use the historical data, and in the historical data, you generate the predicting variable as well as the outcome variable, and put that in the same data frame and make a model. Then you have a new data you want to, like, via the model to do the prediction, because this is why you don't really know, right? You need to know the actual outcome in the future, right? So at the point that you do the prediction, you don't really know the actual value, okay? So, and then you make a prediction, right? So at the time you make a prediction, you don't really know the accuracy of this prediction, okay? The accuracy that you can estimate is basically in the history, okay? That's the basic logic of predictive modeling, okay? So building model is easy, as I tell you, but preparing the data is not an easy thing to do, okay? To prepare the data before you can, we want to make two models, right? In this week we are doing like a probability model to predict the repurchase probability. We want to make a numeric model to predict the expected buying amount, right? Doing model is easy, doing prediction is easy, but preparing data is not an easy thing to do, right? So I want to, like, today I will use two notebooks to help you go through the process of preparing, splitting the data, making the model, making the prediction, and assess the model accuracy. Okay, as I say, when you assess the model accuracy, you are talking about the history, right? And then use that model to predict the future. And that is our purpose, right? If we want to, in the context of business, in the context of marketing, you want to predict this, because you want to do some marketing campaign, right? Usually you're not satisfied with the predicted things, right? If you do nothing, then the prediction would not do you any good. Try to remember the last week's the diabetic case, right? If I just do the prediction, that prediction by itself would not help me, right? But if I use the prediction to plan for my campaign, right? So I would, if I have this probability, if I have this numeric model, with some assumption, I actually can, this prediction help me to design my marketing instrument to choose the target audience that I want to apply the instrument. And then it can help me to estimate the expected outcome when I apply this instrument to this group of selected people, right? That's basically what we want to do this week, next week. This week we are doing this side, okay? Prediction and, modeling and prediction, okay? Next week, I'll teach you how to do assumption and simulation, okay? The reason we do this is only tool. This is not the purpose, okay? The purpose is to design and select marketing instrument, okay? To choose the target audience that you want to spend your marketing budget on, right? And then try to estimate the cost and effectiveness of your marketing things, right? So, and this is basically what I want you to do in your final presentation, okay? So, the logic of the final presentation will be something like this, right? You use data to do model and then do prediction, right? We predict the purchase probability, predict the expected buying amount, right? But this alone will not do you no good, okay? So you need to do some marketing instrument, okay? You sending coupon, you doing advertisement, you do some event, you do discount, whatever marketing campaign you want to do, right? You need to know that how, you need to have assumption that how this instrument would affect, right? Would affect the buying probability. For example, if I send out a coupon, I would expect that the coupon would increase the probability of repurchase, right? If I do discount, I would expect that it will increase the buying amount, right? Okay, so so you kind of do a marketing simulation, right? You simulate how this instrument would change the buying probability and buying amount, right? And then you can estimate the return, right? You have cost of this marketing instrument, and this instrument would have effect on probability and buying amount. And then you can estimate the net expected outcome of each of the instrument on each of the customer, right? I mean, you can estimate the expected outcome, net expected outcome of every instrument on every customer, right? Okay? So you can choose which instrument you want to use, which customer you want to apply that instrument. And after you do that, what is the total expected outcome, right? That is basically the logic that I want you to follow in your final presentation. Yes?
But Professor, how do we know what the amount of the coupon would be? And how do we know by how
That we will cover next week, okay? Okay. You need some assumption, right? If you already are in the business for a long time, you might have some experience. You might know that the face value, because the higher the coupon value, the larger probability it will increase, right? But there will be a relationship, right? It's kind of like you can build a model to estimate the cost effectiveness of each of these marketing instruments. But we do not have data we don't really, and then we are running out of time to make that modeling, right? So in this semester, we simply use assumption, okay? But there are some guideline for assumption. It's not just, assumption is not easy at all, right? Doing assumption is not an easy thing. And that is one of the things that we want to cover next week, okay? Get me? Okay, so actually, this is a very good question. It means that you already follow the entire logic, okay? And that is the most important thing that we want to deliver in this course, okay? So business analytics is not building model. Building model is just one small step in the entire process. That is the one thing that I want to emphasize again, okay? Any question up to this point? Okay, so let's go to the data and the notebook, okay? Now, if we go to this week's the sharing folder, you will see two things, right? The presentation file as well as a zip file. And you will see that the Tafang 5.6, right? Okay? So you unzip the file and put it in your Tafang folder. You should already have a Tafang folder, right? And in Tafang folder, I believe that I believe that there's already 5 and 6, right? You just override whatever it is, okay? Use the zip file I gave you today to override the 5 and 6 notebook in under the Tafang folder, okay? And that is the two notebook that we want to go through today. Get it? Yeah, replace the original. Just override. Okay, let's start with the scripting. Now, before as I told you, right, building model is easy, right? Just a function call, but you need to prepare the data before you can make the model, right? Preparing the data for predicting model is not easy at all, okay? So be careful. So I need to, well, the thing is fortunately, most of the data in the business analytics, they are similar, right? So the process to preparing the data are similar. And after you do the practice in this Tafang case, you can actually use this notebook. If next time you run into the same situation that you want to do predictive modeling, you can use this notebook as the template, right? Just change the, it will make you a lot easier. As I told you several times, right? The most important thing of this course is you need to knit all of the notebook in your own computer. That is very important because nowadays, if you need to write every line of code from scratch, it would make you, it is actually very, very difficult, right? But if you have a template to follow, it will make your life a lot easier, right? Okay, so let's see the logic of data preparation first. Now, first of all, we need to do data aggregation, right? If you still remember, right? The data we have is basically, let me load the data first. Remember to set this as working directory, and then you can like execute the code block by block. Now I already have the 3 data frame here, right? Okay, if you still remember that this Z is the original data, right? And within the Z data frame, it's actually 1 item per record, right? So every record, it has like 817,000 records, right? So this is a very large data frame. Each of the record represents an item within the transaction, right? So we aggregate the item into transaction, and we aggregate transaction into customer, right? The data, the original data is, the unit of the original data is order item, okay? But right now we don't want to analyze order items, right? We want to analyze customer, right? So before you do analysis, the first thing is to aggregate data to the label of your unit of analysis. And in this case, the unit of analysis is customer, right? Okay, so you need to do some aggregation, right? So, and we already have done this in the first half of our the first half of this semester, right? We already done that. So this is the result. But there's one problem though. When you do the aggregation, previously, we actually aggregate, we only have 4 months of data, right? If you still remember, we have like November, December, January, February. We only have 4 months of data, right? So when we do the aggregation, previously we aggregate all of the 4 months data together, right? But if you do that, you cannot do predictive modeling, okay? You need to like, first of all, because to do the prediction model, you need to have the predictor and you need to have outcome, right? Okay? So you have like 4 months of data. You need to like kind of aggregate the first 3 months to make the predictor, right? And the last months, you need to reserve it for the outcome, right? Kind of like I'm using the first 3 months of historical behavior data to predict the 4th month. Because the 4th month I have data, so I know that for each of the customer whether they buy or not buy, right? So I have the buy, no buy conditioned. And I also know that if a person buy, I know that he's buying amount, her buying amount, right? Okay, so that buying amount and so as you can see here that we cannot aggregate the entire 4 months of data. That would not, if you do that, you cannot do predictive model, right? So you need to like, first of all, split the data into like first 3 months and the last month, okay? Okay, and for the last period, you want to know, that you want to make 2 columns, right? The first column is whether this customer buy or not buy. This CID is customer ID, right? Okay? So from the last months of data, you want to know this information, right? And for the first 3 months of data, you can try to do some predicting variable, make some predicting variable. For example, the residency, frequency, monetary, seniority, age, the area, groups, right? Whether this customer buy in Sunday, that whatever you can make out of it, try to make the variable, and then you use this variable to predict the outcome, right? That is basically the ideal, right? So you need to do the aggregation again, okay? And then that aggregation you need to do it on X, right? And you need to do it on Y. Get it? Okay, and then you combine these two data frames so you have a data frame with X and Y in the same data frame, so you can build model. You get it? Okay. And besides, now after you combine these two data frames, in order to estimate the accuracy of your predictive model, you need to reserve some data for testing, right? Okay, so after you combine these two things into the data frame, into the data set, you need to split the data set into training set and testing set, right? And that will be in this direction. See that? Okay, so you need to prepare and split the data in the right way. Otherwise, you will not be able to make your prediction model. Get it? Get me, right? So let me ask you, any question? So why do we want to reserve some testing data? The purpose, we have the training data, right? So we have X, we have Y. So we can build model. So why do we want to split that total data set into training and testing?
To see how good the training data is.
Yeah. You want to reserve some data to test the accuracy of the model, right? You don't want to use the training data to test the accuracy, okay? You want to use the data that is not used in the training process to predict to estimate the accuracy of the training model. That is basically the preferred process in the modern business analytic process. Okay. Okay. So this is the thing that I want to do in our first notebook. Okay. Now let's see. Okay, so we load the data, and then see, I told you we need to aggregate the data again, right? And this time we cannot aggregate the entire 4 months of data, right? So first of all, we need to set the demarcation, the splitting point, right? Which is February the 1st. So first of all, we want to make the predictor, it's the predicting variable, right? And when we want to make this predicting variable, we can only use the data before February, right? we can use the data up to the end of January, right? So so first of all, we subset the data, right? We only use the data like by February the 1st, right? So this is the data in Z. In this data frame Z, layer data up to January, the end of January, okay? It's the first 3 months of data, okay? So using this Z, actually we try to aggregate for the transaction records, right? So we group by transaction ID, right? So the X would be, we will have like 88,000 transactions, right? This code should not have too much problem, right? Okay, this is the basically the day of transaction, customer ID, the age group, the area group of the customer, and then number of item, number of pieces, total buying amount, the raw profit of that transaction, okay? But this aggregation is no longer the 4 months aggregation, it's the 3 months aggregation, okay? Get it? Okay. So, and then do a summary just to check that if they are NA inside. And then we actually do some outliers. We check the outliers, right? So you can see that the mean and median of the total buying amount is just like less than 1,000. But there are some very big, like buying amount, right? There are some very big pieces, right? Okay, so usually we would do some, we'll try to like cut out the outliers because building model, you want to have a general, you need, it is very desirable to have a general model, right? The model is not used to predict the exceptional data point, right? So if you have this exceptional data point in your data, the model is kind of like be misleading, right? So usually we will try to do some, we use this quantile, right, to check that the outlier, the boundary of outlier, right? And we cut outlier. As you can see that we are using the kind of like 9995, right? To cut out the outlier, right? Okay, so it's 9995. We cut out the outlier, right? And then X is just the transaction, right? We need to aggregate the transaction into customer, isn't it? Right? So as you can see that this D0 is just try to, you can see that it's the maximum date plus 1, right? Which means that it is used to calculate the residency, right? Because for every customer, we want to know the residency, right? The number of days since he last buy from us, how many times he did not buy from us, right? So this is kind of the residency. So in order to do that date calculation, right, we need to set the kind of like the last day of the data plus 1, right? So you can use that things to like do the time difference and calculate the residency, right? So this is basically a standard way to calculate the residency, okay? And then you can, for every customer, you can know its residency, seniority, right? See, after you group by customer, now, because X is transaction, right? So if a customer had 5 transactions, okay, the R would be the less transaction, right? Because you are using the minimum days, right? From now, okay? So, and this maximum days is the first transaction, isn't it, right? And this number of transaction, the mean, right? Which the average by the amount, the total revenue contribution, the total gross profit, okay? And then age group and area group. You see this, okay? When you are doing summary, you need to remember one thing, right? Within the summary clause, every expression in the right-hand side of the equal sign has to be a single value, right? Because you are summary into a single value, right? If I use age directly, the age would actually be a vector, right? Because you if you have like 10 transactions in this customer, age by itself is a vector of 10 elements, right? So, but the age should not change, right? Because it is the same customer, right? So you basically just use the first one, okay? Let me emphasize again, within the summary clause, you want to make sure that in the right-hand side of the equal sign, it is the single value, right? When you do a minimum, whatever the day is a vector, right? But you change it into a single value, right? Maximum is do the same thing. Mean, sum, right? So you need to remember this rule, right? Otherwise you will generate some very strange result, okay? Now you after we do the group by, we'll see that 2A5A4. So this 2A5A4 is 2A5A4 customer, right? Sorry. Yes.
Then the minimum days, maximum days, and all of this is for one customer.
Yes.
And then it does the same thing 28,584 times.
Right. 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 This is the way we do group by and summary, right? Because in the X data frame, okay, we actually have AA to A9 transaction, right? This is transaction, and we aggregate the transaction into customer because every customer buys several times, isn't it? Right? That's the process of aggregation, right? Isn't it? Right? So, okay, so we aggregate this transaction into this many customer, and these are the customer that we have seen at the end of January, okay? Remember that we are using this data to create the predictor, right? We are not doing the outcome variable yet. These are the predictor. We pretend that we are at the end of January and we want to predict what would happen in the February, right? We pretend that we are in the end. Of course, we have the time should be here, right? Because this is the data that we have, the end of data that we have. That we pretend that we are at this point, and we want to use the data to predict the last period, right? So that is the point of preparing the predictor. Okay, let's do it in R. Okay, so this is the original data, and we cut it, the first 3 months of data. We do the aggregation. We take some time, right, because data is large. Then you have a total of, so you have so many transactions, right? ATA, AA3, A7 transaction. And then we do summary, and then we take away the outlier. Then we see that access AA295 transaction, right? Then we aggregate the transaction into customer, right? So these are the customer 2A, 5A, 4. And remember that this is for X, right? This is for the predictor variables. Now we need to make the outcome variable. And that outcome variable has to come from the data of the last month, of the last period, right? So February, as you can see that from X0, we filter out the data that the day is in February, right? It's easier. Again, we group by customer, and then we do the we summary the amount, right? So in this February data frame, it's actually very easy, right? Customer and amount. See that? Okay. And these are actually tell us that only 16900 customer buy in February, right? And these are their buying amount. Okay. So this code is easy, right? Just try to, and then we merged February into A, right? See that in A we have 2A, 5A, 4 customer, right? And then in February we only have 16900. The number of customers are different, right? Which means that some of the customers that we have seen at the end of, by the end of January, is not appear in February, right? And when you do the merge, okay, because we specify O of X equals to true, right? So the outcome that would be the same length. I mean that after the merge, the length of A would not change, okay, because we specify that O X equal to true, right? So let's see the results, okay? I want to merge these two data frames by customer, and I know that February has a smaller number of records than 2A, 5A, 4. After merge, take a look at this number. The number of observations do not change, right? The number of the number of variable will increase by 1. See that? See? This is the original 2A, 5A, 4, and 9, right? These are the original A data frame. And I merged February into this data frame. And you can see that the amount variable, there are some NA within this amount variable, right? Which means that because some of the variable that we have seen at the end of January do not buy in February, right? And for those people, the amount will be NA, right? Okay. So you can see that here we have some NA, we have some, right? Because this customer did not buy in February, so this customer's amount is NA. See that? Okay. So so we can actually create another variable, right? If we want to have a variable called buy, right, to indicate that whether this customer buy or not buy in February, right? And it is easy, right? Just to check whether it is NA in the amount, right? So in this line of code, I will generate an extra variable called buy. See? And the buy is the logical variable, true and false. True is buy, false is no buy, right? And for those who have buy, we know his buying amount, isn't it? Right? So we can do a table. So this is number of buying people, and this is the number of non-buying people. See that? Okay. So up to this point, we already have this data frame. Okay? We have this data frame that has for every customer, we have the predictor variable that generated from the first 3 months of data. And we have 2 outcome variable, right? That is generated from the last months of data. And we bind them together as a data set. Okay? Any question up to this point of time? Okay, if no question, let's take a break. And we'll be back at 10 after 10.